All right, today we're going to dive into a really powerful but, let's be honest, often misunderstood software development model. It's called the V model. Think of it as a blueprint for avoiding total disaster. So, let's get right to it.
But first, I have a question for you. What is the single biggest, most hard-stopping nightmare for any software team? Just think about it for a sec.
Yep, that's the one. You pour months, maybe even years of work into a project, and then you find a show-stopping, catastrophic bug just days before you're supposed to go live. It's the kind of thing that can sink an entire project.
And look, this isn't just about bruised egos or blown deadlines. We're talking about a very, very real cost. Fixing a bug in those final stages can be literally 100 times more expensive than catching it early. So how in the world do we avoid that trap?
Well, the problem often comes from older methods, like the classic waterfall model, where development just kind of flows in one direction and testing is this thing you tack on at the very end. The trouble is, by the time testers find a huge problem, it's so deeply embedded in the code that it's an absolute nightmare to fix.
And that is the exact problem the V model was designed to solve. It's built to prevent that last-minute panic by baking quality control right into the process from the very start.
So what is this thing exactly? Simply put, the V model pairs every single development phase with its own testing phase. They run in parallel. Quality isn't an afterthought, it's part of the process from day one, and it all forms this distinctive V shape.
Here's how the flow works. You travel down the left side of the V, planning and designing everything in detail. That's called verification. Then, right at the bottom, at the point of the V, the actual coding happens. From there, you go up the right side, testing everything against the plans you made. That's validation. Plan down, code, test up. It's a simple idea, but it's brilliant. So let's zoom in on that a bit. We'll start with the left side of the V, the verification phases. This is all about the plan, about making sure your blueprint is perfect before a single line of code gets written.
The fundamental question driving this whole side of the V is this: are we building the product right? It's a process check. Are our designs logical? Do our plans actually make sense? It's all about correctness before you even start building.
These phases basically move from the big picture down to the nitty-gritty. You start with requirement analysis. What does the user actually want? Then you go to system design, the overall blueprint. After that, architecture design breaks it into major components. And finally, module design details every single little piece. It's like a funnel, from a broad idea to a super detailed plan.
Okay, so let's hop over to the other side of the V and see how all this meticulous planning pays off. The code has been written, and now it's time for the validation phases. It's testing time.
And the question here is different, but just as crucial. Are we building the right product? See, this isn't just about whether the code works correctly. It's about whether the final product actually meets the user's needs and solves the problem it was supposed to solve.
And here, this is where the genius of the V model really shines. Every planning phase on the left has a direct mirror image testing phase on the right. Those tiny module designs, they're checked with unit testing to see if each little piece works. The architecture design, that's checked with integration testing to see if all the pieces work together. The high-level system design is checked with system testing to see if the whole thing works. And finally, that initial requirements analysis is validated with acceptance testing, the moment of truth when you ask, does the customer actually like it? Nothing is left to chance.
So this sounds incredibly thorough, right? But, and this is a big but, it is not a silver bullet for every project. Knowing when to use it is absolutely key. So let's break down where it works best.
The upsides are pretty clear. Because testing is planned from the start, you catch defects way earlier. The whole process is incredibly structured and disciplined, which makes it much easier to manage. And that rigor is exactly what makes it perfect for projects where failure is simply not an option.
But that same rigor is also its biggest weakness. The V model is very rigid. If the client changes their mind about a key requirement halfway through the project, it can be incredibly difficult and expensive to adapt. And since the coding all happens at the very bottom of the V, you don't have a working prototype to show anyone until very late in the process.
So where does it shine? It is perfect for projects with stable, well-understood requirements that you know aren't going to change. Think about safety-critical systems. We're talking about flight control software for an airplane, medical devices like pacemakers, or secure banking and defense systems. In these fields, you absolutely need that high level of discipline.
And where should you probably avoid it? Well, It's not a good fit for agile projects where requirements are expected to change and evolve. If you're building a mobile app that relies on constant user feedback and iteration to get the experience right, the V-model's rigidity is just going to slow you down.
Okay, let's bring this all together for the final verdict. How does the V-model really stack up, and what's its place in the world of software development today?
When you put it side by side with its predecessor, the Waterfall model, the innovation is just obvious. Waterfall is purely sequential, with testing just tacked on at the end, but the V model makes development and testing parallel activities. This leads to finding defects much earlier and a much higher quality product in the end, especially for those big, critical systems.
Ultimately, the V model is all about discipline. It's a philosophy that builds quality and reliability into the very DNA of your project right from the start, instead of just inspecting for it at the end and hoping for the best.
And that leaves us with a fascinating question. In today's world of agile and move fast and break things, is this kind of intense discipline a lost art? Or, as software becomes more and more critical to our daily lives, is it actually more important than ever? It's something to think about.